Great. So speaking of that, our sponsor tonight is TeamSoft. TeamSoft has been sponsoring quite a few of our meetups. Great partner in this right now, so be sure to stop up and say hi and grab some swag and all the food and drinks are on them tonight. So it's or two drinks, I should say. Other business. So next month, it's going to be back on the east side at Integral. That's going to be March 5th. The speakers are going to be Dan Plachik and John Moser, AE Business Solutions. They're going to be talking about end-to-end container security. Yep, I didn't think I had another one there. So just over some news, we'd like to go through some news in the cloud native world that happened over the last couple of months now because we took last month off. So Kubernetes 1.17 was released in December. I don't think there's any real big new features in there. A couple more things went GA on it at that point in time. Yeah, I know maybe the rest of you, we're behind a couple of releases ourselves, but Cloud Native North America, or KubeCon and Cloud Native Con North America was held back in November, December, somewhere in that time. 12,000 attendees in the North America one right now, up from 8,000 last year, and just 5 years ago, 4 years ago at that point in time, 550 people. So it is really a growing community. And that's just the North America one. I think they now have 3 worldwide, and I think their total attendance was something like 30,000 around the world for the national meetup. So really impressive. Also, CNCF itself is 4 years old. And that's obviously the foundation around most of the cloud native technologies that we go over in this meetup. Obviously, Kubernetes was the first project that was accepted into the CNCF. And the member companies are just crazy right now. And I think I saw now Apple even joined into CNCF. So you have all the big names, Microsoft, Amazon, Google, all part of that at this point in time. And then there's, and those are the member companies that provide tools and tooling and stuff around cloud native, and a lot of big sponsorship. But they also have the end user community, which companies that are just using the software or cloud native technologies can join into. I work at Integral, and we are an end user community. And it's pretty nice to be part of that community as well. They give you some tickets out to the national conferences, but even more so than that, there's a monthly end user community chat that you're on. You can do voting within there. You can join special interest groups based on that and whatnot, and you get a little more insider, to the community. So. Companies that I would really suggest, if you're using some of these technologies to try to convince your companies to join the end user community. I want to say it's like for a company from like 50 to 200 people, I think it's something like 7,000 a year. So it's not that bad to get into. And like I said, you get 5 tickets out to the Cloud Native Conference, which pretty much covers that whole cost. Also 9 new projects graduated, or now 9 projects have graduated, 6 of them graduated the last year. So they graduated, 6 new projects last year. The projects that are graduated right here: Kubernetes, obviously, Prometheus, Envoy, Core DNS, Containerd, Fluentd, Jaeger, Vitess, and Tough. And that's the graduated projects. I didn't get the number of all the projects that are in there right now, but it's got to be probably pushing 100 at this point in time, different projects. Maybe not quite 100, but it's really up there. So there's a lot of good information coming in there. There's a lot to do in that space at this point in time. And the CNCF now supports over 217 meetups, including us. Over 140,000 members around the world as part of these meetups as well. So quite impressive. Again, over the last few years is when they started sponsoring these. 400, right? Yeah, oh, thanks for reminding me. Yeah, so this week we also hit 400 members within our group right here in Madison. So, yeah, quite impressive. So, they also started this last year a jobs board. So the national CNCF, it was announced at Cloud Native this last year, and it's at jobs.cncf.io. So right now it's still relatively new or whatever, but there are some Madison jobs on there. Or if I'm betting there's a whole lot of jobs in San Francisco if you want to go out there as well. But we have much better weather here, so I would never go out there. But yeah, it's another feature of the CNCF that they're trying to help the whole community with. There's also a conference coming up, Deep 608. I don't know if anybody's been to this in the past, but yeah, this is the fourth year of this. It's based around security. It's February 27th at Monona Terrace. I do believe it's free registration, Brandon, is that correct? Yep. It is. And then you can register right there. Keynote Dave Kennedy. We also, our own Brandon Tim will also be doing a breakout session there as well. So great local conference that you can get to, and being free, it's like, why not? So that's coming up at the end of this month. Tonight's speakers, where did my other, did I already go through it? No, I already went through it. Oh, yeah, there it is. Okay. I get confused sometimes. Okay, tonight's speakers are Steve Lowery and Brook, both from Integral. Their talk tonight is around continuously improving CI/CD. So take us a minute to switch microphones for them and get their slide deck over, but welcome them out when they come out.
All right, let's get started. So yeah, like Kurt said, we're going to be talking about CI/CD. I'm going to be taking the continuous integration piece of this. Particularly, I'm going to be looking at it from the angle of continuous testing in CI. This is something I want to talk about for a while at these meetups, but it's one of those things that's kind of hard to find a real good place in the cloud native community. So I'm going to do my best to kind of keep it high level in a way that kind of fits with what we're trying to do here. But before I go on, I do also want to say that if anybody here does want to talk at these, reach out to Kurt, reach out to Brandon, to the Meetup page. I figure if I can do these, you guys can do these. So yeah, so let's get started.
Brooke, you didn't introduce yourself.
Oh, yeah, I'm Brook, sorry. Like Kurt said, I work at Integral. I'm one of the senior engineers there. I started off coming into the organization with the intent of kind of figuring out automated testing, continuous testing, getting that up and going. Nowadays, it's murkier than that, but yeah, that's who I am. So yeah, let's go. All right, so I want to start though by kind of telling a story. I think it's a story that maybe resonates with a lot of people here. We started in our technology stack as kind of a large monolith. We still have a lot of pieces of that in our core application. It's a Space Odyssey reference if you guys don't know. Where the monkey's trying to work on it. So yeah, I mean, the monolith kind of started for quite a while with, what I'm going to call like the romance period. Is things were pretty good. We had a nice, happy family going with that. We were a relatively small team for quite a while there. Everybody had full knowledge of the technology stack for the most part. We had developers on it. We had testers, for the most part, manual testers. We had operations teams that helped with that. All the workflows, the back ends, the front ends are all kind of intermingled in this big monolith. But yeah, I mean, the nice thing about that is I mean, that knowledge was cross-pollinated across most people. It's kind of a long-distance relationship, though. So what I mean by that is, along with that kind of came really long dev cycles, which is pretty typical of these big monoliths, is we had pretty large development cycles of 4 weeks, give or take. We would then pass it over to an operations team that would do their best to deploy the thing out, get it integrated where it needed to be integrated. And then we'd have, like I said, a QA team that was a lot of manual testers. I think our organization had 7 of them, give or take, at one time. And then, if any defects were found during what was, essentially a 2-week manual regression cycle, they'd have to throw it back, get those defects fixed, and repeat the process all over again. So when all's said and done, we're looking at 6-week deployment cycles, give or take, to production. That got expensive, even though those manual test plans that this army of testers went through were pretty robust. They caught a lot of things with their exploratory testing, but it was pricey. And along with that, inherent to the monolith was there was no real delineation between, what our data sources were, what our interfaces were, being able to separate those concerns in terms of testing. Nothing was really tied to a deployable artifact or anything. Test plans were, workflow-based, not artifact-based. And then test data too, because this was deployed out to what was essentially like a staging environment or a pre-prod environment or something like that. And, we have persistent stores in the background. It was essentially a large monolithic database, and to try and manage that data was difficult. So there was a lot of overlap, there was a lot of redundancy, there was a lot of time, and there was a lot of gaps in the quality itself. Because again, we were workflow-based, not artifact-based, so we're trying our best to cover all the workflows. So we kind of went through this phase when I joined the organization about 4 years back, where we try to do some kind of exploration, some experimentation. We try to introduce automation into this process. Quality automation specifically is what I'm talking about. This started in kind of a very simplistic way where we tried to kind of take these manual test plans we had and just automate them line by line, get them out there, show proof of value, try and ease this thing into the culture as it existed pretty progressively. And then along with that, we tried to engage the existing development engineers to start engineering quality code as well, which was something relatively new. We had a pretty good practice of unit testing, but to actually get real quality engineering was something new we were trying to push out. And then these automated tests that we did end up implementing in engineering, they were manually executed for the most part from a local machine. So again, we still had overlap, redundancy, and gaps because we were just automating the existing workflows. We still had a monolith we were dealing with. But we saved a little bit of time in the testing, but we introduced a lot of flake because we're still dealing with the data issues and stuff that exist in the monolith. So we decided to kind of break up with that. I wanted to swap out Kurt's name for developer there, but I didn't. So when I say break up with that, like I said, the monolith for the most part still exists, but we started doing a lot of greenfield development that really freed us up to start exploring, microservices architecture and what we could do with that. So, this is kind of where Docker started entering the fray, containerizing these services, which really kind of empowered us to make everything as deployable and kind of able to integrate as possible in more of a generic way that we could left ship to all the development teams. We didn't need an operations team to do all this stuff. We didn't have to throw it over the fence. And it gave us that separation of concerns that we were really looking for in the monolith, which was, it gave us clear kind of vertical slices of an application to be able to test against, and individually deployable units as well. So what did that look like? And kind of what does it look like right now is, I got a visual here. It's a little busy. Oh, wow, you can't read anything. There are words there. So I'll just go through it quickly, though. So this is kind of a high level, what our CI/CD pipeline looked like and still kind of looks like to this day. So for the most part, an engineer, they'll commit their code to some source code management. We'll have a hook on that. That'll push it out to our CI server. That CI server does a checkout of that code. We do a build, we run our unit tests. We kind of quality gate that to make sure that, code coverage was good on that unit testing. From there, we'll go forward and we'll Dockerize that thing, whether it's an API, a UI. We'll push that out to kind of our artifact repository. And then this is kind of where this CI environment comes into play, this testing environment, which is something new that we architected for this purpose. And this really let us kind of do whatever we wanted with it on a domain basis for the most part. So kind of what I have written here is, we would run test data setup, seed migrates, we'd stand up a database fresh, mock services and stuff we'll talk about in a little bit. But then we'd test that. We'd take the artifact that we bundled up and we'll deploy it out to that environment. And then we'd take some automated tests that were coded up specifically for this artifact and this deployable thing and run those. Again, if possible, we'd run some code coverage on that. And then from there, we'd tag the artifact as good to go out. It's now production ready, it's tagged. And then we'd push it through the higher environments. And then maybe you get a notification or something. So that's kind of what we came up with. That's a lot. So going to these CI environments is this idea of kind of this sandbox environment, this test environment that let us manipulate this data in a really fresh way per integration attempt and ultimately deployment. So it kind of looks something like this, where we started breaking things out into microservices. Instead of that big monolith, we have the ability to kind of have persistent stores, an API on top of that, a UI, kind of dependencies in between. But we still have the issue is, how do you test all of this in a way that still separates those concerns on a kind of artifact by artifact basis? So let's say, for example, we want to target this API 2 in the middle here, and we want to test that. How do we do that in a way that we don't need to assume what's over here that it depends on, or even what's over here that it depends on? So we landed on mocking technology for the most part. What we run with in a lot of our services, wire mock in particular, but replace it with your technology of choice. So we'll stand up kind of a wire mock service inside a Docker container, and in that service we'll register a bunch of stubs that will receive requests and respond back with something we control. And this lets us kind of target specific deployables with all of its dependencies essentially mocked out. And then kind of like I said, we have seed data that we'll put in the persistent store as well, so we can control that during the deployment process too. And that's kind of what that looked like. So it worked good for a little bit. I don't think there's any representatives from one of the teams here in particular I'm thinking of. But we ran into an issue real quick, that as the number of these microservices started to scale, the maintenance surrounding these mocks and maintaining the contracts between them ballooned like exponentially. And then along with that too is we were trying to accomplish what was essentially integration type testing in a mocked out way. And still to this day, we have factions that insist, they don't have faith in what that's actual testing. It doesn't reflect the real world. So what do we do with that? So we want to get to something that's a little more microlithic, which is my word, you can't take it. So we kind of have had this thought on a couple different teams that maybe we'll start using kind of domain-driven design principles to approach this way of continuous testing. So essentially, you need to start by identifying what your domain is. In the previous example, we targeted a specific artifact and we mocked everything out that it depended on. In this example, we can identify domains. You can identify those by persistent stores, by team alignments, by individuals, whatever. So in this example, let's assume this guy here is one of our domains. So what does that look like? So instead of mocking out this service here and having to maintain this mock as time goes forward, or 10 other mocks that this thing depends on, not shown here, all we do is we mock out dependencies outside our edge. And then we still have a robust set of seed data as well. So we can kind of maintain a more realistic example of what that integration looks like in the CI environment. With the idea that essentially you just mock what's outside your borders because you already control everything else. And then we can get fancier with that too, is, wow, you really can't read the text down here. So we can get fancy with that too, because we have moved to Kubernetes. We do have mechanisms at our disposal to kind of make that process of mocking and integration a little more robust. So what we can do is kind of in that example here, let's say we're testing this API. It's sitting out in some pod. But we want to communicate with this guy here. And like I showed on the other slide, we want to communicate with the real integrated thing because it's on our domain. However, how do we test those hard-to-test scenarios, things that you can't easily test with the real integrated thing, like a 503 coming back or some 502 or some other expected condition? So we still, in most happy path cases, kind of have this proxy mock pass-through that will get us to the real service. But we have this sidecar here that if we want to, essentially from our test code, we can say, stub out these negative conditions, like a 503, for example, short circuit that call and respond back. So that still lets us get at those negative cases, but in 90% of other cases, or whatever it may be, we still integrate with the real thing. So that's cool. But what do we do about the higher environments? So we have the CI environment. We've tested these things in a continuous way. We now want to continue this promotion process somewhere else. In our case, we have a couple other environments that are in the way before we get to production. So we want to actually test this thing out in the wild with real integrating stuff. So what we've kind of landed on is being able to leverage kind of health check mechanisms to do a lot of integration testing for us, which I'll talk about in a little bit here. But with cautioning to kind of resist the urge to implement massive regression suites in the higher environments, unless you have entire teams that are dedicated to doing that. Like, don't try and push that effort onto individual dev teams, because there's no way you can sustain it. You run into the same issues you run into with a giant monolith, is because everything's integrated, everything's dependent on each other. And then too, that promotion into those higher environments is gated by things like code coverage, like we talked about in the diagram, but other things as well that I didn't list, like security and licensing. I think Steve will talk a little more about that later. So we can leverage Kubernetes readiness probe to do some of the integration testing for us, which is kind of a standard we've landed on. We'll essentially make an HTTP request out to a readiness endpoint within a container, the thing that's under test, when the readiness probes are firing off. That readiness endpoint, it's implemented in a way to essentially make external calls to all of the hard dependencies that we have. And if that fails, then the pod goes unready until those dependencies are back up, so we don't serve it traffic. So we have a way to kind of test those real integrations that we would otherwise be mocking out in that CI environment when we do our continuous testing. However, one of the contemporary issues we're running into is we can be too aggressive with that sometimes. So sometimes something you identify as a dependency, some microservice on the outside, is really just a soft dependency. Maybe your application is coded to support kind of a down of that application. It has some kind of failover mechanism. You don't really want your pod to stop serving traffic if that's the case. So really, partial service degradation shouldn't always block traffic to a pod. So, and we ran into another issue too, is that when those pods are hard down, the upstream caller kind of loses visibility into what the issue actually was. Because you might have some downstream dependency that's down, causing that pod to stop serving traffic, and now the guy that's calling it has no clue what the issue is. So one thing we're starting to land on is kind of being informative about that integration. So essentially, kind of only readiness what really matters. If you're going to kind of use that readiness endpoint to delegate to other tests for the sake of integration testing, make sure it's only those things that are critical to the application itself. Everything else we can expose through status endpoint mechanisms or something like that, and we can have observability tools and monitors and alerts in place that watch that and alert kind of those issues. So wrapping up and going forward, kind of, where do I see ourselves as an organization, and myself kind of advocating these things is, I'd like to see more adoption of kind of these DDD principles for continuous testing, so we don't run into these scalability issues with mocking. Also, better visibility into root causes for downstream dependencies. If they do end up being down, how do we get more information out of that? And then the ability to test the ingress, of the thing itself. We kind of transitively test that ingress, through these dependency tests and these integration or the readiness endpoints. But in terms of the thing that actually has a readiness probe, how do we validate that ingress? And Steve will talk a little more about that during his talk too. So yeah, lessons we've kind of learned. There's been a lot of them along the way, and we're definitely not done. I'll leave this up here during the transition as well. But monoliths are not testable in an efficient, continuous way. It's very, 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 very hard. I've wasted a lot of time trying to do it. Maybe I'm just not very smart. But so if you can, I mean, and if you have efforts to kind of break your architecture out into microservices, into testable units, like do it. Because containerization makes that way more testable. Left shift your QA processes and implementation, but I've argued, don't stop there. Like left shift your configuration, left shift, your monitoring, left shift everything to dev teams so you can avoid those kind of long cycle times. Proper gating as well in the pipeline, like I said, quality, security, and licensing. Having a testing environment that even allows for that domain level of control of continuous environment, really giving teams the control of that. And then, leveraging dependency testing mechanisms that exist, like readiness probes, for actually testing real integration in those environments. And then, exposing kind of that soft degradation through status endpoints or something that observability tools can pick up and alert on. And that's all I had. I'll just leave that up. So that's it. So we can take questions now. We can talk during the break. I prefer that personally.
There's plenty of food up here. Why don't we take 5?
All right. Thanks, guys.
Hi. We'll start a few minutes early because Andy wants to get going home. So we're a little ahead of schedule. So Kirk got us off early. So I think everyone's had a chance to get some more food, get another drink, and maybe go to the bathroom. So I'll introduce myself. My name is Steve Lowery. I work with Brook at Integral. His talk was a lot about our journey on the CI/CD path and how we've tried to iterate it, make it better. He really focused on integration and testing. I'm going to kind of dovetail off that and talk about delivery. I'm not as funny as Brook is, so that Dilbert comic is about the extent of my comedy in this presentation, so apologies ahead of time. Okay, so you're kind of starting over where Brook was saying, but starting on the delivery side, right? So back in the day when we had this monolith, and we still have this monolith, and it's probably our biggest moneymaker at our organization today, so we're not going to slam the monolith, but we had a single build server managing all the builds. One of the pros, obviously, is of being in an ecosystem like this is it's easy to manage one build server, or it's fairly easy to manage one build server. But it's hard to run day-to-day on it, right? You have lots of builds running, a lot of stepping on each other, waiting for available threads to run on your build server to build the things you need to build to get this application out. As Brook alluded to, we didn't really have any continuous integration or delivery, right? All our automated tests were run most of our tests were manual. The ones that were automated were run manually by a dedicated QA team. And deployments were managed by an operations team running fancy bash scripts on servers somewhere. I think everyone's been in an organization that was at this state one point or another. If not, you haven't been in the industry long enough. Brook alluded to, we had long cycle times. Tiny bug would take maybe a month to push out just because of the processes and the cycle that we were running through. Dealing with branching strategies, right? Anybody who's dealt with long-lived branches and trying to merge something that's been sitting out there for 4 weeks can be challenging and expensive, right? And one of the biggest pain points, right? We're continually doing our deployments at midnight. Sometimes things don't go well and you're still working at 4 a.m. trying to get that deployment out there. And it's involving people from the business to the product owners to the engineers, the lead. Like everyone is involved in those. You have to set up these conference calls. Like, hopefully that's not a place where you want to be. We want to get away from that. We still do some of that, but the amount of that we're doing these days is less and less. And hopefully your organization's trending in that direction as well. And when we originally built our pipeline, we built some job that was, the golden standard. This is what a Java Tomcat application is going to look like, and then we would just clone that, and then you clone it, and you clone it, and you clone it. Now you got to try to make changes and maintain that over time, and it becomes difficult once you've cloned a clone of a clone. right, so let's go to microservices. That's going to fix all our problems. And it did address a lot of them. One of the biggest things was around, just not having this one giant team of developers, right? You break out into teams. We had the opportunity to do some greenfield development with launching some new products, so it was a natural time for us to, delve into microservices, right? So it allowed, which one's the laser on this? There we go. Subject matter experts to emerge, right? You don't have this huge product anymore. It's a little easier for some of these team members to actually get into the details and know their products a lot better because their domain that they had to know is a lot smaller. Now we were spinning up multiple CI/CD server, or one per team, but we had multiple of them across the organization, so allowed for greater throughput because teams weren't waiting on other teams' stuff to run. We were able to better organize the code base by breaking into domain-specific repos owned and maintained by those product teams. So that was a win for us. And teams, getting into two pizza teams, right? Where you're dealing with a team of 6 or 7 instead of a team of 25 to 30 people. And we didn't jump into the Kubernetes pool at the beginning. We kind of dipped our toes into Docker initially, and we had some simple orchestration frameworks. We could issue automatic rollbacks for failed deployments, so that was a really big win for the organization. I'll say we got to a point where we were doing near zero downtime deployments, but not quite zero downtime deployments. So we could get to a point where we could deploy some of the things during the day, but our big critical applications, there wasn't a lot of confidence that we could do that during the day, so we were still doing maybe not midnight deployments, but 10 p.m. deployments and so forth. Now, application teams were managing their own deployments, and they were no longer dependent on an operations team. Like, that was a big win for us, but it will come, and I'll get to it a little later. It comes with its own challenges, right? With great power comes great responsibility. Somebody said that once. And now we had a shared pipeline that all teams consumed. So we didn't have clones and kind of one-offs, and a majority of our deployments looked primarily the same. So that was a nice iteration of our delivery pipeline. But now we have all these CI/CD servers all over the place. And now we're trying to make sure that all the tooling is staying up to date and they all have the same capabilities. And how do we manage that? And that was something that we kind of struggle with, and still to some extent struggle with today. Like I had alluded to, we still had potential customer downtime for misconfigured applications. So while we had automatic rollbacks in place, customers may have still seen that the service was unavailable until that rollback had occurred. So it was progress, but it wasn't quite where we wanted it to be. So again, that was forcing our hand and saying, what we still got to do these off hours. And we initially ran all of our CI builds only off of master. So it was really hard to test a new feature without merging it into master. And then you run into the issue where this thing is in master, and now I got to get a hot fix out there, and it's not quite vetted out yet. Now you are struggling to create a branch of a specific commit and doing all that fun. So that was a challenge that we're still facing after our first iteration of our pipeline into microservices. So now like I mentioned, we had this shared pipeline. It was managed and maintained by a single team. Its maintenance was cumbersome and difficult. And we still had a lot of dependencies on like our operations team. So we still have had to create tickets for things like I need a new database spun up, or I'm creating a bunch of new services and need load balancer configuration, DNS, networks, et cetera. That was all still managed through tickets to dependent teams and slowed down delivery time. And similarly, we had secrets being managed by a security team so that to be compliant. But yeah, that was providing a lot of delay in delivery as well. So we kept iterating. We were able to upgrade our delivery system to be able to build off of any branch, and it's been kind of a game changer, right? We can now test, features in an isolated branch, even get a human to look at it, a PO to sign off on it, make sure it looks good before it gets merged back in, and then potentially shipped out to production. And we have plugins that we're using Jenkins CI and CD for CD right now, and it has plugins that kind of manage all that for you, creating those new jobs, tearing them down when the branch gets merged in, et cetera. We got to true zero downtime deployments for almost all of our workloads. I don't want to go into the details because it's not really relevant to a continuous delivery talk, but so now we do deploy a lot of our things during the day with confidence, knowing that if something goes out and it's misconfigured, that no customer is going to see that and get their traffic routed to that pod. It'll get rolled back automatically by the pipeline. Teams will get notified. It will have failed, but no one would have really been none the wiser. And we've gotten to a point where our shared pipelines are now, scripted. They're community maintained, so anybody in the organization can contribute to them, following the same SDLC principles as a normal application, where someone has an idea for a new feature or a bug fix, they can put it into a branch, push it out there, gets reviewed by some of the maintainers, and gets merged back into master, and everyone takes advantage of it. It's been a really nice way for us to evolve that pipeline faster, as opposed to having an individual or a single team kind of trying to manage that for the entire organization. We've also been able to start some self-provisioning tools for our application teams to be able to put that operations work in their hand. They need a new database spun up. They can do that themselves now. They need some networking. They can do that themselves now. We're not all the way there yet, but we're always continually trying to make it better. Secrets managed by application teams. This was a big pain point in, I'd say, V2 of our pipeline here. It's great for application teams. I'll talk about this in a little bit on what our problems still are, but the teams don't have to wait for someone else to go, enter their secrets into the production systems. And we were able to build license compliance checks within the pipeline. So before an artifact gets deployed to production, we are able to check against to see that all the licenses of the things it's using are approved for our organization before it gets promoted to production. That makes our SecGov department pretty happy. Yeah, so these are some of the our struggles that we're still having today, right? So we haven't yet automated the functional tests of our ingress resources. So I don't know if that's something people have ideas of. I'd like to hear feedback from how other teams are doing this. But we're pushing out services, but not necessarily in the higher level environments. We're not necessarily exercising calls through that public ingress to make sure all the ingress is configured correctly. I don't think we've had a ton of issues with it at this point, but it's definitely something that can go wrong as part of our deployment process. I said secrets are managed by the application teams. I think the application teams love this, but our compliance teams kind of hates this. So we're working through that right now to kind of make both sides happy, and I'll get to that in my next slide about what we're doing to evolve our pipeline in the future. And our teams have, right, like I said, with great power comes great responsibility. Application developers now are not just being asked to write code, they're being asked to know all these things about the systems and the platforms on which their code runs, and it becomes difficult to manage for someone who just came out of college and learned C# or Java or Node, right? Like now I have to be expected to know Kubernetes and Helm and all these different observability tools, and how can we as an organization help them with that and help relieve some of that burden from them? So our teams are doing a lot of work in that space that they just don't have the expertise in right now. So where are we going from here to take that next step in our pipeline, in our delivery pipeline? We are, Kurt, you got to take Hannah to karate at 7:30. You're going to be late. I better hurry this up. We're going to reduce the number of touch points. We're going to attempt to reduce the number of touch points for these application developers so that they can hopefully more focus on the application, not worry about operating as much. There's always going to come that burden. I don't want to use the word burden, use it lightly, to operating their application. But what can we do to help them make that easier? We want to get monitoring as code. Monitoring right now and observability is kind of an afterthought. I don't know if anybody's doing this right now. If you're doing this right now, I'd love to talk to you. But get it so that that interface that they're using to configure and deploy their application, we want to put that, put your monitors and alerting right there beside her and get it deployed out to production with, with the same interfaces and pipelines that we have today. Building out a secret management platform that's integrated with the delivery pipeline so that our application teams don't have to even think about those secrets. Those get managed by the platform itself, and ideally rotated at regular increments, and get into some advanced deployments, Canary, Blue, Green, etc. I believe the talk in April we're gonna dive into that if that's correct, right, Brandon? Not we, I'm not gonna be talking, so yeah. So that's so lessons that we've kind of learned, and I think this is on 2 pages, right? Continuous delivery is hard, right? You're not going to be able to if you're not doing continuous delivery today, you're not going to be able to go back to work and, deliver this in a week, right? It's something you got to work toward and strive towards. And whatever you choose, like I said, find a piece, whether if you're going into new lines of business and you can take that opportunity to build something small and iterate on it, or even if you have a monolith and you have no plans on changing that, you can if you have new features coming in, maybe you can use that opportunity to break that out into something that's not part of that and start working in this type of environment. And we don't do this today, but it's something I've given a lot of thought to. Separating your CI pipeline from your CD pipeline, I'm not trying to be controversial here, but I think that's a good practice. It gives you a lot more, there's a lot of tooling in that CD pipeline space that we haven't explored yet as an organization to kind of help you with those more advanced deployment methodologies that something like Jenkins or Travis or whatever might not be, that might not be the best tool for that. So I think that's something we'll probably at our organization be doing at some point in the near future. And from experience, I'd say strive to make those delivery pipelines something any developer in the organization can contribute to. Some of the best things in our pipeline today were not contributed by the team managing them, but by just developers who saw opportunities to make it better. For instance, Brook talked about that sidecar mock proxy built into our pods. Like that came from just an application developer who had the idea, who contributed that back. Make zero downtime deployments a goal from the get-go. It'll lead to better outcomes, and your developers will be a lot happier. And I think most importantly, accept that you will make mistakes along the way. You're not going to get it right the first time. Be okay with that, but be ready to learn from it. I think that's it. Well, I know that's it. Unless there are questions. Andy's still here, so I did my job.
How often, you say that you've got it all in place for automatic rollback deployments.
Mm-hmm.
From when you put it in place, like how frequently does that happen in your actually day-to-day experience?
Yep. The question was asked, how often are we having to roll back failed deploys? That's a good question. I'm not on one of the product teams. I think those product application teams probably have better answers, and it's probably variable on those teams.
I think we're at about 10%.
Are we?
And it's mostly due to a configuration or like what Brook talked about before, when we had those hard dependencies, when they shouldn't be hard dependencies, they rolled back and there really wasn't anything wrong with it. I think we're at about 10% overall.
Yep. Yeah, we're using Helm to kind of manage our deploys, and you attempt to do a rollout, and if it times out and the things don't become ready within that timeout period, which by default is 5 minutes, the pipeline issues a rollback.
How do you manage your deployment versions? Like, is it all through Jenkins and Git, or what?
Yeah. So Brook kind of alluded to that in the first slide. So what we do is we push. Well, the question was, how do we manage the versions for our deployments? So we use semantic versioning, and what we do is we initially push out. We build our Docker containers, and we push out with a Git tag of whatever the Git hash was for that commit, and that gets pushed out, run under test, and if it passes testing, then we increment that semantic version number, and we have some conventions that say if the commit message has a bump major, bump minor, and then it'll bump the major or minor, else it's going to be assumed to be a patch version. Then that semantic version is what gets deployed to environments higher than an integration environment.
And the hotfixes too, would it be?
Hotfixes would be like that patch, yeah.
Okay.
So 1.0.1 would go to 1.02.
Okay, but whatever is in the latest in your repo gets deployed, kind of if it passes through CI and all.
If it passes through CI, it's going to, well, yeah, the normal workflow is put it into a feature branch. It'll go out. It'll get tested against with all the automated tests that run against it. And we actually push it out to our integration environment for a human to validate, or if they want to. And then we have gates that say, okay, that looks good. It gets merged into master, and then it can go beyond that environment.
Can you give us some examples of license, as part of your quality gate, you had a license compliance kind of check?
Mm-hmm.
Like, what are you checking against? Like, what would fail? Like, a couple of examples.
Like, so the question was, license check examples, license compliance examples. What are we doing there? So, you're building any type of app, we primarily build Java and Node apps. You're pulling in dependencies from open source software, right? So Node modules, Java libraries, whatever. We publish, we're using a product called Artifactory to pull that stuff in. So we publish, it gets cached into Artifactory when it comes in. And then we check against those, any repo should have either in their README or a license.txt. Artifactory kind of manages what's the license of this thing. Is it MIT? Is it Apache 2? Is it WTFPL? There's a bunch of different weird licenses. But it manages that, and then we have a process that we built in place that says our organization supports, these are the approved licenses. So then it kind of just takes, here's all the dependencies that this artifact has. Here's our approved licenses list. Are there any that are in violation? And if there are, then the pipeline stops, spits out a report and says, go fix these things.
Great, thanks. Going back to your version, so you have Artifactory, but you also said that you're using so you're not using named version of Artifactory to do the deployment or the rollback. You're using the Git. I thought there's no Artifactory to make that. My question is,
Yep.
when he was asking about the versioning principle, it is based on Git commits.
The Git commit is just, we use the Git commit just in that first environment so we can, because we don't want to give it a semantic version if it doesn't pass tests, right? So we want to have a version to push out there. I mean, it gets tagged with latest as well. But if...
At what point of time it goes to Artifactory? Is it after the CI part of it, or?
We go to Artifactory after we build it. We build it, we run unit tests against it. If that passes, then we Dockerize it and push that to Artifactory with a Git commit. Okay. Then we run integration tests against it. And if those integration tests pass, then we give it a real version and say this thing's ready to, it's passed testing, it's been validated, it's a candidate for release.
Can you talk about how things might be different with a major release where you're maybe deploying changes, like breaking changes to like a database where you're doing like one-way changes to your database that are either super challenging to roll back and how that might affect kind of the whole process?
Okay, so the question was, how do we handle major releases? The TLDR of that is we just don't do that. right? We have practices, right? We don't break our contracts. If you need to iterate, like for example, our APIs are all tagged, the URL has a version number in it. So if we're gonna totally change what that is, we're gonna change the URL that you have to call to V2. Like we try to adhere to some of those practices where everything's backwards compatible. Because yeah, it is a huge challenge.
And at a database level, we'll do multiple deploys.
Right, so you do one that
Yeah.
maintains the backwards compatibility, you make sure that everything is fine, and then maybe the next one would
Right.
make the changes.
Yeah, like a common example of that is you want to add a column that's not nullable, right? So like our typical pattern was you'd add the column as nullable. You can add that whenever you want. You don't have to coordinate a code change with a database change. Then you make the database change, or you make the code change that then starts populating that, and then you follow that up with another database change that then locks it so that it's not nullable. Or probably has to go update all the null rows to whatever that default is, and then marks it as not nullable.
I was hoping you had some magic.
Oh yeah.
Oh, yeah.
Just do it, yeah. Yeah. Well, thank you, everyone. Like I said, next month, pipeline security. Thank you.